So hello everyone, I'm again here to cover the remaining part of the second unit. And last time I covered till this crease or flex resistance test. So today I'm starting with this coefficient of frictions. Means what is the importance of coefficient of frictions in case of packaging material and how we test it. So all surfaces are rough to a greater or lesser degree and they exert different forces on objects resting on them and which act parallel to the surface and resist sliding motions. This force is called frictions. Coefficient of friction or this COF, both static and dynamic or kinetics, are a measure of ease with which the surface of one material will slide over the another. The film which move easily over various surfaces have a low coefficient of frictions. So for your use ease also, I can make it very simple. For example, there are two packaging film and now you wish to test what is the coefficient of friction of the film. Then you will place the two film together and if the film you can slide the film easily over one another, then you say this the coefficient of friction is less. So again, to make you understand in a better way, I have video for this and you will be happy to see it again. So this is the test setup in which the first of all they are fixing the first seat, and after that they will place the another seat over this seat. So this is the seat, okay, and this is the another seat. Now this seat is not fixed. The down seat, the bottom side of the seat has been fixed with the clamp, and over the seat now they have placed a weight. This weight will be attached to the machine with a kind of thread, and now this when the test will start, this arm of the machine will move towards upper sides, and this weight is helping the film that is under this weight to slide over the film which was on the base. Okay, I think you got it. The top film is sliding with this metallic bar. So here you will see that this top film will appear after some time. Here you can concentrate, see this will appear after some time. It will take bit time but it will appear here. So I think yes, this is the time. Yeah, here you can see this seat has easily sliding over the bottom seat or the under seat, and so how much of force is required to slide this seat over the bottom seat is a measure of coefficient of frictions. So sometime when we are dealing with the packaging material, then we have to pile up, and if the coefficient of friction is very high, then it is not desirable characteristics. For example, you have to continuously pack, like you stack and then you are continuously packing something and you are sliding the packaging bag over one another, and if the coefficient of friction is high, then that characteristic will be not desirable. So it is about the coefficient of friction. And next I'm going to talk about, I think, blocking. Yeah, blocking is another characteristic of the packaging material in which what we determine, basically we use to determine the force required. For example, we have piled two, means we have made the intimate contact of two packaging film and we ensure that there is no air inside, and it usually happens when you pile up the packaging film over one another's, like you are a bag supplier and you have to transport it over a distance of 100 kilometer or 200 kilometer. Then you will prepare a bundle. So this, if the blocking is characteristic is there inside the packaging film that was used for the manufacturing of the bag, then when they will try to use the individual bag, then they will try to detach or depart that individual bag. And if the blocking strength is very high, then it can cause damage to the bag even. Sometimes the two get remain attached also. So this is the blocking, and it is a surface property, and it also depend on the temperature and the pressure of the environment. Sometimes there is some film which under the effect of temperatures they have so more adherence and their blocking is means comparatively more at a normal temperatures, and same is the impact of the pressure. If the pressure you will increase, then also the blocking and this blocking characteristic of the film can be affected. So during manufacturing, some anti-blocking agents are added in the film just to avoid the blocking characteristics. So how this test is performed, again I'll have a video for you guys, and I'm sure you will enjoy it. Yes, this is the film with short video film. Here you can see, yeah, this is the test setup in which there is a rectangular slab and we have fixed a packaging film on the lower bar, and then we have applied the packaging film, same packaging film over the another rectangular this probe which are attached. So first of all, what you will do, we will press it, we will apply a force just to ensure that there is no air between, and then we will start the test. And as we will start the test, here you can see, you please focus on this line. This is the line which will indicate that how much of the force is required to detach these two specimens from each others. So I have started the test. So as the test is up leading or approaching, so the force has been exerted. Slowly it is increasing, and we have to wait for some time till the time it get detached from each others. So if you will focus here also, then there is a small gap is increasing. The gap is increasing at a say it is slower rate, not at a faster rate. But now the detachment has start, but this is continue. So for your, yes, see, now this is detaching from each other and it is continuously recording the force required. And the test is, we are running the test as a very slow speed so that we can assess the force required, the minimum force required. Because if you will run the test all of sudden, then see this here, this is the final detachment will takes place under the effect of force, and now this plot is coming down. So see, blocking is simply that how much amount of force you require to detach the two adherent or intimately closely spaced packaging film. I think you got it. Fine. So I'm not playing it further. And after that, the last topic from this unit, not this unit, from this section, is the orientation and the shrinkage. So for orientation and shrinkage, I'll say that a packaging, whenever we carry out the shrink packaging, then what we do kind of some kind of heating. First of all, we use to wrap the material, and then we apply a little heat. And with the application of little heat, it wrap the food material very tightly. So that is the shrinkage property, and it is desirable when you are dealing with this kind of food packagings that you wish to make it appealant, and you are preparing a food packaging film, you are preparing a food pouch in which there are some stuff is there, and you want that food stuff should be visible to the customer. So you may have seen some kind of wrapped packaging film of this what do you say, this one of the Khumani is the Hindi name. I don't know the exact name. You may have eaten palm, I think, this palm tree, and nowadays that palm is supplied in the this polystyrene tray covered with a wrapped films. So there are so many article on the rack, food rack, if you will visit a retail store, so in which we carry out shrinkage. So shrinkage is a desirable characteristics in one case, but it is not that desirable when you are dealing with a packaging film that is it's used for some kind of product in which we are keeping them in a adverse environment or in the open environment, and some kind of harsh condition may take place, like if we are not aware that how much temperature rise may takes place in a day if in the final locality where we are distributing the food product, and if the shrinkage strength is not that good, that high temperature can cause the shrinkage, and sometimes it can even attach to the food product. So this is the orientation is something that whether it is a machine direction and cross directions, that is basically carried out in case of paper material, but for wrapping and packagings we use this shrinkage. So it doesn't affect the physical and mechanical property, but it affects other properties. The shrink tension affect the appearance and the performance of a film in a shrink packaging application. So basically we determine shrink tension. Shrink tension affect the appearance and the performance of a film in a shrink packaging machine. So for this again I have a video, and that video will help you to understand in a better way. So in this video, what is there? Let me mute this sound. And there is a kind of machine in which there is a provision of heating. So here there is a tray in which we will carry out heating. So, so down there, here there is a kind of disc in which we can carry out heating. So how to perform the test? First of all, we take the packaging material, and then with the available die. This die is this circle is according to the disc size of the machine where we are going to keep this specimen. So now we have determined the dimension of this material, and we will apply little silicone oil over it so that it doesn't stick to the this lower disc, because we need to perform other tests also. So now we have preheated it, and then we will start the machine. And after starting the machines, we have test fix the time temperature, and after some time there will be a sound, hooting sound, and we will remove it. There will be a hooter and we will remove it. So we will determine the change in the axis, major and minor axis. So there is a formula on the basis of which you can calculate that how much shrinkage has taken place. Major shrink 75%. Yeah, this is the formula in which the unrestrained linear shrinkage percentage can be given by LO minus LF into 100 divided by LO. LO is the initial length, that is diameter we take 50 mm, and LF is the length after the shrinkage. So divide by original length into 100. So this is defined in case of the results are described in term of percentage. So, okay, fine. So from second unit, this is the part 2. I'll not going to record the remaining part, because the remaining what are the remaining part of the second unit. So this is the last unit, the last topic of the available slides, and the remaining three topics that I'll cover in the next lecture. And now I'm preparing small videos, because when I'm trying to upload the larger videos, then also I'm getting difficulty. So these barrier properties, polymer relationship, and measurement of permeability. So let me brief you about what I'll talk in the next lecture. I will talk about the barrier properties. Barrier properties means, for example, we have packaged a food product in a plastic film or in a polymer film. Then how able that polymer film is to restrict the entry of water vapor or any kind of gases, so that the wholesomeness of the food products remains unaffected. So how this transfer of the moistures, you can say sorptions, takes place, then that moisture is finally transported to the food product. So there are two three law like Henry law, Fick's law, and some sort of equations are there. So that is bit more complicated, but I'll teach you in a very easy way, don't worry. So further, after this, I'll record only short videos, and I hope you will enjoy these videos. Thank you very much. And if you have any query, okay, I'll forget one more thing. The last time I was talking about this tear strength. Yeah, tear strength is where? Yes, well, just a minute. Huh? This is the tear strength. So in the tier strength, there are two methods. One is the ASTM D199. Sorry, this one ASTM D1004 and ASTM 1938. So actually, in this case, we can determine two strength. One is the last time I shared a video and I said this is a tear propagation test. Actually, it was not a tear propagation test. It was something else. This is tear resistance test. This video I have shared with you in the last lecture, and this test I said that we have made a intentionally slit over here, and then we are determining how much force is required. So I'm sorry for that one. Actually, this is the test in which we use to determine how much force is required to induce or to produce a tear or to create a slit inside the sample. Understand? And the actual one in which we use to determine how much force we need to apply to propagate the tear. There are two things. One is initiation of tear. So obviously to initiate the tear we have to apply how amount of force, and later the tear propagation force requirement will depend on the characteristic of the film. In some cases it is very less, and in some cases it is not that less, it is significant amount. So next test is this one actually that I this is the test. So they are making a slit. Now they have made a slit here. Okay, yeah, and now they will clamp this. Yeah, you can see, I think. Yes, this is the test in which we are determining how much force is required for the tear propagation. So this is all about from this lectures. So stay tuned for the next lecture, and I hope for your better health and you may be enjoying with the family times. Okay, good luck. Thank you.